Hi, my name is Shaun Wallace. I am a current PhD candidate in computer science at Brown University. Crowdsourcing tasks allow people to collect and curate label data from multiple annotators. Then labels are often aggregated to create an annotated dataset suitable for supervised machine learning tasks. The most popular label aggregation method is majority voting, where each item in the dataset is assigned the most common label. Relying on a simple majority will not work in this scenario. Users come with their own biases and perspectives that can affect their labels. This labeling task should be straightforward. Is this a picture of Barack Obama? I would assume the majority of people would say yes. If we asked if this picture was inspirational, then the labeling task is subjective. Maybe someone's political affiliation or personal history can cause them to have a vastly different feeling than someone else. That bias will surely affect their label. But imagine a world where we can account for personal bias, given a labeling task by relying on a user's voting history. We developed the Debiased Label Aggregation method to begin to study this difficult problem. DLA relies on users' voting history to calculate weights per item vote per user. For example, we have 3 crowd workers with the following voting proportions, which determine the following weights. We can use these weights to possibly change the final label. DLA leverages patterns in users' voting behaviors across multiple items within a dataset to improve the quality of the aggregated labels. DLA also includes another variation, where we introduce a simple normalization procedure to account for some users having more voting history than others. To develop DLA, we use a public dataset of sketches with binary labels. After applying DLA, we found that around 35% of the final labels flipped compared to majority voting. We used an XGBoost model to compare the classification performance of the same ML classifier trained on 3 different label aggregation approaches. Initially, DLA shows some promise. Previous work has shown that any label aggregation method really benefits from a large number of votes per item. Therefore, aimed at investigating the scalability of DLA, we tested the effect of increasing the number of collected votes. For this, we duplicated each vote 5 times. Comparing the classification performance of models trained on majority voting and our 2 proposed DLA variants, we find that considering the user's bias when weighting the votes produces labels that improve overall classification performance. DLA's improvements outperform the baseline performance of majority voting by a large margin in some cases. This improvement after data augmentation was expected, since each item has more information about the agreement distribution of user votes. Most importantly, DLA is simple to implement. It only needs a user ID, an item ID, and the user's label to produce the weights to help remix the ground truth data. Please visit our GitHub repository to find out more. We are really excited to share what is coming out next.